Iceman50 here. Um, I wanted to talk to you guys about a project that I'm thinking about. I kind of saw some different things online and on YouTube more specifically, and I had an idea for a pretty cool clock. And I was like, okay, so I have this little tiny hard drive, right? And then I was like, well, how am I gonna get a clock on here? So I was like, what would I even do? And I started searching for miniature clocks and all that, and then I thought, of course, you can't really get a small clock, like tiny, or can you? And then it came to me, just get a watch. So the idea is that this thing will be kind of sitting in an angle. I got this idea. I have a hockey puck cell phone holder. They just take a hockey puck and they cut a groove down the middle of it, like this. You can see it's round. This is where it's cut out. Here's the side view, and just another side view of, obviously it's just a circle, but I took some measurements, and this thing fits in there perfectly. So it'll sit at an angle. And then I was thinking, okay, so we'll get this. Oh, hang on. Get this watch, and this was cheap, like 12 bucks or something, but we'll strip this would be kind of like this, but we'll strip this watch out of the casing and everything. And the one cool thing is that it lights up. Oops, can you see that? Let's turn off this upper light. We'll turn off this light. Oh, it's so dark. Okay, anyways, so what it'll look like is something like this. Here, let's turn off my light all the way. So see? Pretty cool. The question is, how we're going to be able to do this. And the answer is, I don't know. But one thing I do know is that I don't think I want this to have a battery in it. I'm thinking what we'll do is we'll pop this off. And I think these, it runs on a 3-volt pack. The battery, I mean, 3-volt pack, a 3-volt battery. So what we'll do is, we'll go in here and we'll wire up some wires and come through the back of here somehow. I haven't figured it out yet, but maybe we'll go through the middle here or something. We'll just bring some wires down here through the middle and come out, and then I think this might work. I think this is a buck boost converter. I've got a bunch of these in a bag, but basically the idea would we bring in 5 volts or something, and then we'll just mount this back here, and then this will drive the we'll drop this down to 3 volts, and we'll drive the watch. And then we also have to figure out about this. I'd like it to be either lit all the time or a switch or automatic, with a photo resistor, a photo cell. That way, if it got dark enough, it would turn itself on. But basically, with a watch here, if you push this, it lights up, right? Well, if you push and hold, it shuts off. And the reason is that, the watch is controlling that. You just can't keep it on forever, like if it was accidentally pushed. So we're going to have to find where the wiring goes for that, and then we'll have to come up with something. Now I've got these little tiny tack switches. I got to find them, but basically they're like these. What we'll do is we'll have to solder some teeny wires, and we'll bring out, like, if you want to use the different modes, like there's a timer. Where is it? That's the light. There's the mode. There's like a timer, so you can start it and stop it. I thought that was supposed to clear it, but anyways, we've got a couple of different. You got to basically you got a count up timer. Oh, and you got an alarm, so you can set an alarm. Well, that would be pretty cool, and we can set the time, right? So I thought it'd be like a cool, alarm clock kind of thing, that you could just set next to your bed or something. I don't know. So what we'll do is we'll 3D print some kind of ring to hold this, and then we'll just bring wires out. And I was thinking, like, if it's like this, basically I would just mount the I wonder if I can come I don't know if I can come through there, but you know, we'll just mount like there's the 4 buttons. We'll just make like the 4 buttons here, and we'll bring the wires in somehow. We'll do something anyway. So I just wanted to explain to you guys what we're trying to do, and the first thing to do, I think the easiest thing to do is going to be to print this hockey puck looking thing. So what we'll do is we'll open up our drawing program. Escapes SketchUp. It's early, guys, on Saturday morning, and I'm feeling a little funny. I think I got a cold. Hopefully it's not the cold, but we'll go over here. We'll go to SketchUp. And I drew this in inches. I'll go between millimeters and inches, metric and inches, because you know, whatever is easiest. This I thought, well, whatever. So right now I've got it set as 3D printing multimeter. So we'll choose the template, and we'll go to 3D printing inches. I'll say start using SketchUp. So the disc is 3 inches in diameter. So we're gonna start, and then the gap is 0.7 of an inch. Okay, so I think what we're gonna do is we're gonna erase that. Then we're gonna come here. Okay, we're gonna get the circle tool. Okay, and we're gonna go right at the origin, and this does it in radius, right? So we want a 1 point, radius is half the distance of diameter, right? So it's 1.5 inches, right? Okay, then what we're gonna do, I think, is we're gonna draw a line from our center out. Come on. Okay. Alright. And then we're gonna split the difference for this channel. So we found the center line, right? And then we'll split the difference. So 0.7, right? So what is 7 divided by 2? It's what, 3.5, right? So what we'll do is we'll go 0.35 inches from here. We'll go 0.35, and we just move it up, and we say 0.35. Now, mind you guys, I am not an expert CAD. See, what's cool is that when sometimes, like, so in this case we went this way and we're coming back this way, it knows. It's snapped at 0.35. It's giving me, it's saying, oh, you want to make it just like that one, which is pretty cool. So you just hit enter. Oh, I waited too long. There we go. And then you click it again, and boom. Then we can go from here, and we can go, as long as this is red, it's parallel to the red axis, right? So come over here like such. Always make sure you red you did. Okay, so now that should be our channel, and then if we come over here to our I selected the dimensions tool. If we go from here to here, look, you can see 0.7, right? I know, kind of sucky because this is right on the axis, but we'll just do a Control Z. Okay, so the reason I've done this is so we can split and remove our lines if there are any. So we can split this and raise it up. You see this profile here. We gotta, it's this thick. It's 1 inch thick, and then but we've got to, we're gonna come up with 2 separate profiles, right? We're gonna subtract 1 inch from 575. That's gonna be our height, and then from there we're gonna go we're gonna go up 5.7. Yeah, we're gonna go up 575 to the top. So, well, what we're gonna do is, I don't think we don't need the center line anymore. Okay, so now you got to use your push-pull tool, which is this guy, push-pull, and then what I can do is I can come up. We can come up 1 inch, and then I can just bring the center section down 575. So what we do is, you see, you click it, and you pull up, and you can just say 1, enter. It is now 1 inch thick, right? And then we'll rotate around. See? And then what we're going to do is we're going to push-pull the center section, and we're just going to, you can come over, and if you drag your mouse over here, it'll be the same, it's on face, it'll be the same height. So you just click it. So what we've done is we've made 3 pieces, right? And then all we have to do is drop the center section 0.575 of an inch. So we grab our push-pull tool, we come at the top, and we go like this, and the numbers down here are going to be negative, right? So you say, you've got it going down, you say 0.575, enter, boom. We now have the hockey puck. It's done. I'd probably put this in Thingiverse anyways. I find it's great for tablets, cell phones, whatever. I got it as a gift. It's literally a hockey puck with a milled end in it. So now the next thing what we're gonna do is what we should really do is see if I can put my logo in here. So let's save this. So we're gonna save this as puck base. Okay. So let's see if I have antenna holder. Let's see, what do I got here? Okay, this is for a different. That's for my my REM puck. Let's see here. Open. I swear I have. It might be on my desktop. Let's see here. Oh man. Okay. Let's look here. Osmo mount bracket. No. Oh, here we go. Here's my logo. It's the coaster. That's this thing. Remember we made this? So we can stick this. How are we gonna do this? Can we bring in? See, I must have had files to. I must have had files. For that. So we'll go to puck base. We're gonna say file, import, STLs, and then we're gonna come down here. That's under documents. That was on my desktop. GI logo coaster. Import. Hopefully we'll be able to scale this. I mean, I don't see why not. I should be able to use the scale tool. That's right here. So it's doing its thing here. It's importing geometry. My next door neighbor, my upstairs neighbor, is already blasting some kind of hip hop. This guy has no shame. You know, what time is it here? It's 7:53 on a Saturday morning. This guy started 20 minutes ago. Whatever. So we're just gonna wait, and I'll edit this out, and we'll bring you back when I got this done. I'll be right back. Hey everybody, here's I think Plan B. I don't know what's going on, but we're using my laptop here. So what we're going to do is we're going to export STL. This is an extension for SketchUp. So I always do export units. We're going to do it in millimeters. It's better for the printer and for the software. I mean, I designed it in inches, but it doesn't matter. So we're going to export it in millimeters, and the file format is binary. So we're going to say export, and it's going to ask where, and I'm going to just save it to the desktop again. And it's going to be called Puckbase STL. Okay. It's going to take a second, I think. Let's take a look. Puckbase. Okay, so what I've done here is I already brought in my logo, and we can kind of, I think what we can do is we can play with it here. We'll click on Puckbase. We'll open that up. All right, boom. Empty layers detected. It would not be printable. Okay, Puckbase. This is usually caused by negligibly small extrusion or by faulty model. Try to repair the model. Yeah, so I've noticed this. Yeah, shh. Okay, so obviously it like turned it black, you see here. Okay, it's saying there's errors, right? And that's okay, because I found that every time I mess with this stuff, the new pressure slicer is great. I'm using 2.20. They've got a built-in, you click here, the editing, it's got built-in NetFab, repair through NetFab. This is pretty cool. NetFab is made by AutoCAD, and I had a copy of NetFab before, just standalone, and I could fix models and stuff. It's a really great product to have if you're doing stuff off of Thingiverse or whatever. But it's cool. They like baked it right into Pressure Slicer, so you can just click fix through NetFab. It look, it's already done. It fixed my model. It's now manifold. You can see that, that the errors are gone. It's now manifold. I can move it around. See, we can look and see what it looks like, right? So, where is the coaster? Where the flock did that go? I don't know. Let's no. How do we delete that? There we go. Okay, so let's try adding it. And we'll say GI logo coaster. Now we should be able to scale this, right? So we should be able to pull this off here. And then we should be able to select the scale. And we should be able to zing, bring it down, 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 right? And then okay. And then I love that movie. Okay. So the question is, how can we do this? I never tried doing this before. Oh, interesting. That makes it thicker or thinner. I don't know. I don't know how to do it yet. We're not going to waste time. We're just going to click this. We're going to say trash you. We're going to do this. We're going to set our infill like really low. We're going to set it like 5%. Okay. So it's still going to, even at 5%, it says it's going to take 1 hour and 41 minutes, and it's going to use 9 meters of filament. Wow, that seems like a lot. Anyway, so yeah, I'm hoping this is correct. Seems big. So it's 90. Oh, Yeah, well, we know Z is correct at an inch, so basically we're at 76 millimeters, and since it's a circle, they're the same. So 76. Okay, so just quick rule of thumb, obviously, uh, millimeters convert to inches by a factor of 3. So if it's 25, so 1 inch is 25.4 millimeters. So obviously we're at 75. So if you just kind of round up, round down, 75 divided by 3, which is the diameter I wanted, is 25. So we're at 3 inches. So we're good. Uh, okay. So we don't need any supports or anything like that. What we're going to do is we're going to turn on the 3D printer here. Oh, God. I really need to replace the fan in this power supply. Ah, this is so annoying. Okay, well, there we go. Kind of, sort of, close enough, right? Okay. I know, everybody, I need to clean up.